already we have learned data movement operations in SICXE machine. So here data movement operations that is performed in SICXE is shown with the help of an example. So here LDA #5. So it is similar to the SICXE itself, a small difference. So here task is like we need to store this value 5 to a variable alpha, and some character z will be stored in the memory location C1. Okay, alpha and C1 will be some memory variable, and it is reserved as one word variable and 1 byte variable. Okay, so reserved for storing one word, alpha is reserved for storing one word, C1 is reserved for storing 1 byte. So 5 is a constant value which will be stored to the accumulator first. That is LDA. LDA helps in storing the constant value 5 to accumulator, and then from the accumulator, using the instruction STA, it stores the value to the alpha. So before that, we need to reserve some word memory location for this alpha, storing this integer value 5. Now next is like you need to copy the value z or store the value character z to the memory variable C1. So in SICXE directly we have done. In SICXE we are using some other method, like first you are loading the ASCII code for the character z. ASCII code value for z will be stored in the accumulator, and then you need to store the value from the accumulator to the memory variable C1, which is reserved for storing 1 byte variable. So in such a case, we are using the instruction STCH, not STA. We made use of the instruction STCH, which means accumulator will be having some value and which will be stored into some character, some memory location which is designated to store a character variable. Okay, so this STCH, what it does, it will be taking the value 90 from the accumulator and it will be converting to the character variable z based on the ASCII code and stores it in the C. Okay, this is data movement operation. Then next is related to arithmetic operations. So in same arithmetic operation we have done in the SICXE example also. So in this case we are using calculation like this. Beta is equal to alpha plus increment INCR minus 1. Delta is equal to gamma plus INCR minus 1. This calculation you need to write in program. So here we are as we have learned, we are having many registers in addition to the registers given in SICXE. Some 4 registers are there. We are making use of those registers to perform this operation. So instruction LDS is used in order to store the value INCR into the register S, that is loading the value of INCR to the S register. So in order to perform this calculation, what you have to do first, you need to declare these variables, or some space need to be reserved in the memory. So what all are the variables? Alpha, INCR, gamma, beta and delta. So alpha is these 5 variables are listed out here. 5 variables they are listed out here. Okay, these 5 variables it is listed out here, and these variables it is reserved as for a 1 byte, one word variables we are defined for all these 5 variables. Now using the program first what we need to do? We need to load the value of INCR. Some value will be stored in INCR which need to be loaded to register S. Similarly, load the value of alpha to LDA. So, loaded these two variables alpha and INCR. Now, next is like add registers S, A. So, performing the operation alpha plus INCR. Performing the operation alpha plus INCR. Result will be stored in A. Result will be stored in A. Then perform the subtraction operation. So sub #1 integer 1. Then store the result to beta. So store the result to beta. Okay. Then what does it store the result to beta from? Accumulator will be having some result which will be stored to beta. Then load the value of accumulator with the gamma. Next statement you are executing. Gamma value, gamma is a variable which is reserved for one word constant. It will be loaded to the accumulator. Perform the addition operation, that is S, A. S is having the value that is INCR, comma A. So this addition operation will be performed. Now perform the subtraction operation. That is the result will be stored in A minus 1. The result that is stored in A will be again stored to delta. That is, the result after subtraction will be stored to delta. So hence these two computation will be performed. So this is a program in order to perform these two computations. So if any equation or something is given, if you are asked to write the programmings, you need to use this procedure. So some equation, till now we have done this some examples based on copying as well as performing the arithmetic operations, movement and arithmetic operations. So next we can see looping and indexing. Looping and indexing. In case of looping and indexing, this also we have done in the SICXE machine architecture. Same example we have done. So here we are defining this T register. What is a program does? We have to copy the string, test string. Test string we need to copy and place it into string str2. The two memory variables are there, str1 and str2. str1 will, we are initializing str1 with a string, some string name, and that string you need to copy it to str2. So str1 is initialized as a byte constant, 11 byte constant, because the length of the string is 11. Since we are copying the same string to the target variable, we have to reserve that variable memory location with 11 byte. Okay. So this is the declaration part, and then moving to the program. It's a looping. So we are giving a name for that, move ch. Character by character, you will be storing the string characters into the target variable. For that, T register, T and X register will be used. T register will be used to store the number of characters that need to be copied. N value, here it is 11, so it is initialized with 11. Then X register, index register, it is initialized to 0, so that count can be monitored. Then index can be monitored. Then LDCH, first character from str1, using this index register value 0, from the str1 you will be copying, you will be loading it to where register A. Okay, str1 is having this string x is equal to 0. 0 means it will be placing in the this T, 0th location. So T will be loaded to accumulator first, and then using the STCH function, T will be copied to STR2 in index location 0. Then TIXR. TIXR means it will be incrementing the value of index register. So one it will be incremented and compares the result with what the T register. Okay, TIXR means it increments the index register value by 1 and compares the result with the T register. What does T register have? It is having the value as 11. Okay, then jump if less than. So jump if less than to move CH. So this is used for looping condition. When it loops with the value obtained in the previous condition. Previous condition is it checks with 11. If the value obtained from X register after incrementing is less than 11, then jump to the label move CH. So this will be continued till the value is equal to 11. Okay, till the value is equal to 11. When it equals to 11, it means that the string is copied to the second STR2. So this is the case with looping and indexing. Similarly, there are many more examples in the textbook also. So this is one example that we have done in SICXE2. This also we can do. There is index register is you are storing the value 3 to a S register, 300 to T register. LDX will be initialized with the value 0. That is, here we are performing the addition operations of some two numbers. We are performing the addition operations, retrieving n number of times. Here 100 words each, 100 additions we can perform. 100 numbers you can take, perform addition. Each time you will be taking 2 numbers. So 100 times this loop repeats to perform the addition operation. So here we are giving this 300 because one word will be equal to 3 bytes. So in order to maintain that, we are making use of 300. Okay, one word is equal to 3 bytes. So automatically the address byte will be incremented by 3. To be incremented by 3, hence the result final count it should be equal to 300. So you can just go through this example. LDS is equal to 0. Looping statement starts. LDA accumulator. Some alpha value will be stored in the accumulator. Index location is 0. Add beta. Beta also it is reserved for 100 words. Alpha and beta will be added. Result will be stored in gamma. Index location 0. Once addition is performed, what it does, index register will be incremented by 3, which means 3 bytes. Compare the result with the T. Compare the result obtained with T. So T is 300. So 03 means it is less than the 300 value. So add will be, looping will be performed. So this 3 will be used for incrementing the address bytes, and 300 is like in order to check with the 100 words or 100 iterations. Then it performs addition. Once it reaches to 300, it exits from the loop. So similar examples are there in the textbook also. You can check with those examples.